Real quickly, yesterday's lesson, I did a quick poll, and I got 4 big booms for the lesson. Right? Cool. So, in today's lesson, we are continuing on from yesterday. Remember, oxygen and fluorine or nitrogen or hydrogen, when they bond, they make these poles, right? North pole, south pole, and there's charges. Bam, bam.
I got a question. What's B again? Like
What's what?
B?
As a chemical symbol? Boron. Where is that from the homework?
No. Because I forgot what it means.
Okay, yep, there's B, which is boron, and there's Br, which is bromine. Are the two that I think of. Number 5 is B, hydrogen, helium, lithium, boron. Yeah. Okay, so check it out. Remember, they're attracted to each other because of these charges, the covalent charges, and oxygen's bigger, so it pulls electrons harder. Slight negative, slight positive, which means these stick to each other, right? And we watched yesterday at the end of class the video of the water bouncing on water, and that's a highlight of the adhesive and cohesive properties of water. Okay, the actual name for those things, they're hydrogen bonds, because it's hydrogen bonding with something else and creating this polar charge, and it's a result of the van der Waals force. Okay, all that is the magnetic, quote-unquote, magnetic attraction that we get when we have polarized molecules. Awesome. So today we're going to take a pretty big switch here, but we're still continuing on. This is still 6.3, and the last thing that we talked about was hydrogen bonds. Today we're going to jump in with something a little bit different, but it's our second main topic, and we're going to talk about mixings or mixtures with water. Now, water does a fantastic job of dissolving other stuff. Have you guys ever heard, and I think of The Wizard of Oz, which, just quick question, you guys know about The Wizard of Oz?
Yeah.
Have you ever seen the movie?
Yes.
Interesting. Like the original?
Yeah.
Cool. That surprises me. What happens to the Wicked Witch of the West when she gets water on her? She starts yelling something.
I'm melted.
Okay, fantastic impersonation. It has bugged me for like, I don't know, 20 or 30 years, depending on when I learned it. It drives me crazy. Even nowadays, like, people still, like, oh, what are you afraid of going out in the water? Are you going to melt? Like, people make that dumb joke. I don't know if I'd call it a joke. I don't, maybe. But it's wrong. Give me an example of something that you've seen melt. Ice melts because you're taking the solid and you're turning it into a liquid, right? Okay. Now, if I were to put Kool-Aid into water and stir it, is it melting?
Oh, no. Mixing. Yes.
There's a better word for it.
Dissolving.
It's dissolving. The Wicked Witch of the West most certainly did not melt. It happened when they poured water on her. She dissolved. It drives me crazy, but it just doesn't, like, melting isn't the right word.
But they just turn like some steam, like, you know.
I don't know. I'd have to look back at it, but it's always bugged me, and I'm confident that I have a reason to rationalize it, but maybe there is some steam involved. Either way, I still don't think it's melting. Okay, regardless, here we go. We're going to be talking about mixtures with water, and it's not the most exciting thing to just hit vocab stuff, but we need to make sure we agree on what a mixture is. Okay, what's a mixture?
When you put two stuff together to make one.
Exactly 2?
Or many.
Ooh, and then bigger question, does it really just make it one thing? Or is it just 2 things that are now mixed together?
Yeah.
Like, if I mixed powdered sugar and flour together, they both look just white powder, right? If I mix them together, I still have just a bowl of powdered sugar and flour. They just happen to be mixed up. It's not like I've created something new, powdered flour. Or, yeah, that flour's already powdered, so that's a weird statement. But they're different still, right? Okay, that is a mixture. Now, it could be 2 things, it could be more. By definition, we're just going to say that a mixture is a combination. And there's an important part that comes after this. So if you're thinking, I don't need to say it's a combination of stuff, there's an important follow-up. It is a combination of 2 or more substances, And that part's not crazy, right? You mix stuff together, that's what we're thinking of. However, if we're talking a mixture, it's 2 or more substances where each keeps its characteristics. Where each and I want to say thing, but that's not very formal. Each component, so whatever it is we put in, holds chemical characteristics. And I'm going to use keeps instead. If you are working on the vocab, Andrew, I appreciate it, but I'll tell you, the late grade between now or a week from now is identical. Like, you're better off staying up here and getting that in at your earliest convenience. Okay, combination of two or more substances where each component keeps chemical properties. Okay. Notice, I did not say physical properties. It could keep its physical properties, but definitely keeps its chemicals. If I mix a bucket or a batch of Kool-Aid, I still have water in there, and I have Kool-Aid in there. I could separate them without having to do any chemical reaction. If I leave a container of Kool-Aid out for 6 months without the lid on, when I come back, is there liquid anymore?
Yeah.
You think so?
Like,
Let's say it's a cup, not a big mix.
Okay.
You ever leave a cup out and notice that somebody's secretly coming in when you're not paying attention, drinking all your water?
Yeah.
Are they really sneaking into your house and drinking your water?
no.
What's happening to it?
Looks like you bad.
It just evaporates, right? Now,
With
water
it.
evaporates, right? Is your Kool-Aid going to evaporate?
No.
No. Now, like if you've ever seen your parents leave a coffee cup, or if you drink coffee and you leave a coffee cup out, if somebody leaves it, eventually there's just a brown stain that's not wet anymore, it's dry at the bottom, because all the water is evaporated out. Now, looking at it, we can separate those. Now, in our mixtures, there's two types, and this is always a weird thing. It depends on who you talk to. There's some agreed upon things. You guys have probably seen some of these words. Remind me, you are academic in this classroom, despite the words that show up. And I know we had this discussion earlier. Something that's the same. Do you remember what we call it? And in my mind, without like trying to push any sort of agenda, if a woman is attracted to women, so that's a less formal word than I was expecting, but you're right, like that's the common language that we use, right? However, in general, forget about gender, whether it's a man attracted to a man or a woman attracted to a woman, they're what sexual? Not A means without. Bi means both, so you would have to have a woman or a man attracted to both genders. Alternatively, that's another, okay. Without it, we've used it before. We're just going to define for ourselves homogeneous. Okay, now real quickly. When you see this, homogeneous. From time to time you'll see this pronounced as homogeneous to avoid that, but I think it gets away from the root. Homo as a prefix has nothing to do with sexuality. That's what we associate it with in our culture in modern days, but all it means is same. So, same genius. Now, same composition is all we mean. So, homogeneous or homogeneous mixtures are just mixtures, and I'm going to say mixture. Sorry, forgot it. A homogeneous mixture. All that this means is that everywhere throughout it, once I mix it together, it's all the same. That's that homo prefix. We're just going to say uniform composition. Uniform composition. Now, this is where it gets kind of murky just in how we're talking about this. If I look at salt water, for example, if I have water and I mix some salt in and I dissolve it in there. If I were to look and take a sample and it's completely mixed, let's say I've mixed it perfectly. If I were to take a sample and test how much salt's in it and then I tested another sample from somewhere else, they'd have the same amount of salt because that salt's been dissolved in all the water, right? It is the same everywhere or homogeneous. Okay, I've mixed stuff together, but it's the same everywhere. Now, whether or not it's truly exactly perfect is hard to tell. My coffee in my cup over here, just kidding, it's this one. My coffee in this cup is coffee. It's coffee at this point, it's coffee here, it's coffee everywhere, right? Okay, now, in contrast with that, we are going to go a little bit further. Homogeneous mixture is kind of a lot of words to try to sneak out. So underneath, we're going to sneak in one more definition. We're going to define a solution. And can somebody remind me the shorthand that I use for solution? S-O-L. And then if you have the apostrophe or not, doesn't matter. It's soln. Solution. Okay. A solution. All this is a synonym for homogeneous or homogeneous mixture. A solution is just a mixture whose composition is uniform. Now, water is special in the fact that it dissolves a ton of stuff, like way more than any other liquid that I'm aware of. When we're talking about a solution, there's two parts. We get what is called the solute, which obviously comes from solution, right? Like these are linked together. And this is just what is dissolved. What gets dissolved. So in my example from a second ago, where I made salt water, what was the solute?
Hot water.
So what did we actually dissolve?
The coffee.
It was, so in that,
Kool-Aid and
so that was a harder example. Let's use the salt water because that's a little bit more natural. What dissolves in water to make salt water?
Salt.
Salt. Okay. In that example, salt is what we call the solute. It's just Kool-Aid is a solute if you make a batch of Kool-Aid. Okay. In contrast with that, we have another word that I doubt you ever heard, solvent. Okay. Now, a solvent is what does the dissolving. Not what gets dissolved, but what does the dissolving. And that sounds like a question, and now that I'm writing it, it sounds so strange. But in the context of speaking, does that make sense? So what the stuff is dissolved in is another way you could word it, but that's like 4 more words, and I try to be lazy. Okay, so in a cup of salt water, the solute was the salt. What was the solvent? The water. Water is so good at this that it's often referred to as the universal solvent. Stuff that will dissolve, if it will dissolve, pretty good chance it will dissolve in water because water is special. Okay, beyond that, we have some solutions that are the same, and I'm just going to do this, and I'm going to draw arrows, and forgive my spelling because I never remember. A synonym. These are the same. What I can't remember is if synonym has an N on the end. I don't think it does. A synonym. Big. What's a synonym of big?
Small.
That's an
Large,
antonym.
Little.
Also an antonym. But small and little are synonyms. Big, large, those are the same thing, right? Okay, a solution is just a homogeneous mixture. Okay, in contrast with that, there's stuff that I can mix together and everything gets mixed the same, and no matter where I checked, I'd get the same stuff. Can you think of anything that we mix together that doesn't happen with?
Doesn't have
Oil.
So oil just won't mix at all with water, right? So this is gonna feel weird, and whether you'd probably come up with another one. I'm gonna give us an easy one. Have you ever eaten a salad?
No, no.
Or you've seen a salad at least? Okay. Anybody in here, when you eat salad, it's nothing but just pure lettuce, right? That's the only thing. It's a salad is just a plate with just lettuce on it. Is that true?
No.
Yeah.
Very rarely. I don't eat just regular lettuce salads.
Yeah, you add.
What else is on there?
Like
Ketchup.
chicken.
Mayonnaise.
So you might have some chicken. Interesting that you're adding. So ranch is what I'm going to say is your mayo. I think ranch is terrible on salads, just for the record.
What?
Don't like it. Don't like the way it combines
Do you
something.
eat blue cheese with wings?
No.
No. Okay.
No. I'm a good person. Do you?
No.
Oh, okay.
I always eat
All right. I was hoping you would, so that felt like I was. Okay. But if I had a salad in front of me, realistically, there's going to be some lettuce. There might be some shredded carrots. There's some dressing, right? When I mix it up and I make this salad, can I still look at it and go, oh, it's lettuce, and I can see it, and there's still carrot, and there's a crouton. Like, I can see the differences, right? Is that the same everywhere then? If I picked up one little batch and I say, oh, it's just lettuce, and I picked up this batch, oh, it's lettuce and crouton, those are different. That is no longer homogeneous or homogeneous. In contrast, because it's not the same or homogeneous everywhere, it's different. Using that same cultural language that we see with sexuality specifically, homosexuality means attracted to the same. What do you call somebody who's attracted to the opposite? Not quite. That'd be both, right? Bi means two.
Straight sex.
So straight's the common word. You're not wrong. I'm going to start it here, and somebody's going to finish it. Heterogeneous in this case, but yeah. A heterogeneous mixture. Okay. Now, just to make sure that it's not super weird, instead of saying this is uniform everywhere for homogeneous, I'm just, instead of saying not uniform, I lied. I'm just going to say not uniform. Or if you'd rather, if that doesn't really mean anything to you, different. At least slightly everywhere. Now, give me two other things that you would mix that you think would wind up in a heterogeneous mixture. And there's a lot of answers that it's going to bridge the gap sometimes, I think.
Hot water and sugar.
Say it again.
Hot water and sugar.
Hot water and sugar. Does sugar dissolve in water?
Yes.
So if I mix it perfectly, everywhere in that cup, do I have sugar water? That would be homogeneous.
Oh.
And they don't even have to be liquids for mixtures and things, just so you guys are aware.
So-
If I go out to Front Beach and I pick up a bunch of rocks, and then I go out to Summers Bay and get a bunch of sand, if I mix them together, like I could mix up sand and rocks. However, is everywhere in there just going to be sandy rocks or rocky sand? Or is it possible to reach in and I grab a big rock and a very little sand, and then I reach in and I grab just a handful of sand? Is that possible that those are different in composition? So that means it's not the same everywhere, which means it's no longer homogeneous, but instead it would be heterogeneous. Okay, there are some fine lines where things get weird. Typically, not always, but typically we can see the difference between homogeneous and heterogeneous with our eyes. Not always. How many of you guys drink milk
When I eat cereal.
when you eat cereal? Okay, so first comment, it's super weird that we drink cow's milk. That is bizarre for even any milk. Like,
Even bizarre for myself.
that's a weird thought too, for sure. There's probably some really terrible tasting milks that people tried first and didn't wind up going with. Anyway, is it weird when you see, I don't know, an 8-year-old drinking milk?
No.
Okay, now in nature, just the natural world without our modern culture and stuff, have you guys ever seen an older animal of one type suckling on an animal of a different type?
Yo. Adult.
So you've seen a grown dog suckling off of something else?
Yeah.
I've seen a baby dog suckle. Do you guys know what suckle is?
Yeah, like
Like to be on, like to get milk from the mama, right? Okay.
Oh, like
You've seen like an adult dog latch on to, so a puppy definitely. Babies do that, right?
What you mean?
Well, that it'd be weird, right? If how old's your dog, Bam Bam?
Huh?
How old's your dog?
He's like 1 year old.
So he's close to adult. He's not a puppy.
Yeah.
Okay, let's say that I had a cat. I don't have a cat. But if I had a cat that just had babies and she was, milking and giving milk to the babies, would it weird you out or you had a cat rather, because that makes it easier. Would it weird you out if you went home and you saw your pit bull drinking milk from your cat?
Oh yeah.
That would be strange, right? That doesn't happen.
Wait.
But you don't bat an eye if we look at a large human drinking the milk of a different animal. Like, it's bizarre. Anyway, that's one point. Milk. What's your gut say? Heterogeneous, homogeneous?
Heterogeneous.
Why? Interesting.
Because it's. Oh wait, it might be. The other way.
Yeah, I'll go better.
Why? Argue it.
Like it's in reed. Oh wait.
So let's just forget it. We don't care about the different types of milk. Maybe that was a weird little sidestep that I took. If I have a cup of milk in front of me, all from the same animal, or out of the same gallon of milk. Cool, like cow milk probably. If I take a sample of it and look at it, do I say, oh yeah, that's milk? And if I take another sample, am I going to look at it and say, oh, that looks different? If I take 2 spoons of milk, do they both look the same?
Yeah.
Why no?
Because
I
saw
just
goat
feel
milk,
like it would be
it's kinda-
different. Like depending on what they eat and like what health the cow is in.
So, but
the
remember, we
day.
got milk from the same cow.
Oh, same.
So here's an example that will probably work. This is hand sanitizer. It kills germs, right? What kills germs in here?
So,
So the alcohol is what really kills them. I'm okay with the idea of soap. Now check this out. I don't think this is pure alcohol. It's a gel, right? So they're mixed together somehow. Check it out. Here's a glob of it. Looks like a glob of hand sanitizer. Here's a glob of it. From the same bottle, right? Can you guys tell the difference here? Like, you can come look if you want.
No.
that looks like hand sanitizer, and that looks like hand sanitizer. If I did the same thing with a cup of milk, I think we'd see the same thing, right?
Oh, so that's it.
So I'd be tempted to say that milk is homogeneous, and if one made the claim that milk was homogeneous or homogeneous, I would accept it. I'd say, okay, yeah, that's fine with me. However, this is where this gets weird and depends on who you're learning it from and whatnot. If we look at milk, and we use modern technology just to look a little bit closer, so with microscope. If we looked at some milk under a microscope, this is what we actually see. This is what it looks like. Now, anybody here loves skim milk?
Skim milk? What's that?
Skim?
Is that chocolate milk?
They take all the fat out of it.
Oh,
Is that what you drink?
Sometimes.
I don't mind it. It's okay. I think whole milk tastes better. The red one, if you buy it at the store. Now, when you look at milk, can you tell me any things that are made of milk? Like other things. We use milk for a lot of purposes.
Cheese.
Cheese is a good example.
Pasta.
What?
Wait, you don't make cheese with pasta?
Pasta is what you said. Not directly. It's more flour. You can make it with milk in it, right?
Butter and ice cream?
Butter, ice cream, those things. Is butter healthy or not?
No.
No.
Not really. Why?
Because it's too much fat.
Too much fat. Okay, check it out. When you zoom in on milk, what you wind up seeing, these little things, these are just little globs of fat. Like there's fat in your milk, and it sounds gross, but it's what makes it delicious. If I look at this under the microscope, if I look at this little sample on the top left, does it look different than this sample right here?
No.
You say no, and I agree with you to a point because they're all just little globs, circular globs of fat, right? But what's right in the center of this one? That little tiny glob, right? If I take this sample, what's right in the center of it?
A big.
So they're similar, but they're not exactly the same, right? One could then, if you look at from this viewpoint, you could say, whoa, 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 it's not the same, this is heterogeneous. And a lot of it depends on how closely you look at stuff, which is where it gets weird. I just want to make sure that you're aware of that little strange thing that happens as people are talking about homogeneous and heterogeneous mixtures. Okay, so, oh, go ahead.
Is milk healthy for us then or not?
Not particularly.
Oh, okay. Because I know a lot of people said like it grows your bones when you're like your period.
Oh, 100%. There was a huge push in the 90s for got milk, and there's still a poster in the lunchroom that says that, I think, with Miley Cyrus, probably from 15 years ago. Man, it's really good advertising. Really good. If I sell milk, let's say I'm a dairy farmer and I sell milk, if I at all have people start thinking it's unhealthy, people buy less milk. But if I spend a lot of money up front to make sure that everybody in the country knows just how good for you my milk is and how strong it makes you and how good it is for your bones and stuff, people buy it. I think that our cultural connection to milk in the modern, just everywhere in the world this happens, I think that it's just one of the best advertising and propaganda campaigns that have ever happened. Like, they obviously want to make money, and they're making a lot of money considering that every single school in the country has to buy and provide milk for kids. Like, there's a lot of money at hand. I'm not going to say milk is unhealthy, but there's better things to eat or drink to get your nutrients that milk provides. Cool. Just for the record, I didn't do it at the time, but if we could time travel 30 seconds, my teacher hat came off, and that was a little bit of my personal viewpoint. What I just said about that is not fact. Okay, that's just my opinion. I should have made it clear before I spoke. Okay, so just a quick little example here. As we're looking at heterogeneous and homogeneous, I'm just going to make sure that we have the examples, and these are really simple. A sand, ooh, this is a good one. What if I mixed sand plus water? And I'm not asking for what it makes. Is this a heterogeneous? Like, I know it's just sandy water, right? It's dirty water. Is this heterogeneous or homogeneous if I mix sand and water? Is all the sand, does sand dissolve?
Yeah.
Does it?
No.
No, the little dust, which is just small sand, I guess. But sand's just little rocks, right? So it doesn't dissolve in there, which means, is it possible that if I mix this up, eventually stuff's going to fall, because I know that's what's going to happen if I mix sand in with it. But if it's just been mixed and I take 2 scoops, is it possible this scoop has way more sand than this scoop? Like, just because of the way it's distributed, right? Like, maybe I took one a little bit higher or lower, and now they're different. This would be hetero. I can physically see the difference between the water and the sand as I look at it. And that's a good rule of thumb, with the understanding that there's some weird parts. Okay, if I mix those two together, that is hetero. What if I were to do, air in this room. And like this air around us is made of a bunch of different stuff. There's some oxygen, there's some nitrogen, there's some hydrogen, there's probably some not great things in it as well, just because anywhere on the planet that you are, that's going to happen. But small enough that it's not a concern to us. Air in the room. If I were to take this sample and I were to count and look at it, like even with technology really closely, I'm going to see all those things, oxygen, nitrogen, whatever, blah, 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 right? If I come over here and take this sample in the same room, am I going to see the same stuff? So I honestly, this is a weird one, I'm okay with either. I think that it's safe to assume that everything is mixed pretty uniformly in here. I would argue that I think the air in here could be homogeneous or homogeneous. In your book, they present this as homogeneous. Bam Bam, you were of the no, and I think I have to agree with you as well. And this is that weird gray line. I will not give you guys curveballs where it could be either or, but is it possible that this sample of air has a little bit more oxygen than over there? That's where the hetero would also be argued. You can write heterogeneous in yours. I will not throw a wonky one like that at you guys. It could be either. Okay. All right. This one's a little bit easier. What about, flour and sugar? If I mix those together, am I guaranteed to get the exact same amount or ratio of sugar to flour from this scoop as I am this scoop?
Wait, what was the question?
If I mix flour and sugar together and I put them in a mixer and I let it run, is it possible that I scoop out one and I scoop out from a different place and they have, this one has a little bit more flour, but this one has a little bit more sugar? It's reasonable that that probably happened. It's not going to be perfect, right? Nothing dissolved in it. Which means if these are different, is that hetero or homogeneous? Would it, if it's not going to be the same, I wouldn't say both. This is hetero. Because we can still, it'd be tough, but you could physically go through and pick them all apart, right? Okay. One more. I'm okay with those. I will not throw you curveballs. Cool. All right. Now, with heterogeneous mixtures, there are some specific examples that wind up that we deal with. Specifically, we have two new words that we're going to learn, and we'll write them down briefly. But if you look at salt water, is it perfectly clear? No. And if I were to mix salt water, and if you've never done this, we can mix them today, and then we'll look at it again tomorrow if we need to. If I mix salt water and I pour way more salt than can actually dissolve, if I mix hard enough and fast enough, it looks like it dissolves. And then if I stop stirring and let it set for like an hour or a day, what do you think we're going to see the next day when we come back? See what? It might be blurry. Is it still going to be mixed up from the day before, do you think? Ooh, so we're going to hold, like, maybe. I like that idea. I will mix up some salt water at the end of class here, and then we'll just leave it till tomorrow. So take a look. Okay, as we're looking at it though, one last little piece with these mixtures is sometimes mixtures separate. You guys ever seen a bottle of salad dressing where it's all the oil and stuff on top and all the clunky stuff, it looks gross on the bottom? Then you shake it and it's fine again, which it just looks gross. It's not really gross. Okay, what you have there, and in fact milk winds up being kind of the same with this, is we have two different ideas of mixtures. We're just going to sneak in two additional vocab real quick. We have a suspension. Now, I have a good example of a suspension. It's a weird one, but check it out. In here, did we look at this last week? Okay, so this is, I don't know what the fluid is in this, but it's kind of like a jelly type fluid, and there's some iron in it. Right now, as I look at it, do you see that that iron's just hanging out? Like, it's not sinking, it's not rising, it's just hanging out, right? So the fact that it's not moving around in here, I'm just going to use the language, I'm making the claim that the iron filings in there, those little specks, are suspended. They're not settling out, they're not all falling to the bottom, they're not separating, they're just kind of intermixed within, right? Here it is. They're not frozen. And in fact, I'm going to show you guys something cool with this here in a second. But those are suspended. So that is a mixture. That mixture, I'm going to put this on the board so people can see it. Maybe if you want to see it there, just so you can. I'm going to put it on my camera up there. Okay, this is a mixture. Is this mixture homogeneous, or is this heterogeneous? Heterogeneous. I agree with you completely. Can you convince me of that? Like, argue it a little bit.
Like, you take out the. Wait a minute.
Yep, so that's metal in there.
Wait, is it in the tube or is it all around?
It's all around it.
Oh, okay.
So it's all suspended in there, right? And I can see that maybe this sample has a bunch of more iron than this one. Okay, but it doesn't settle. If I just don't touch this and I look at it tomorrow, all of them are going to be in essentially the same spot. Now, for that situation, and I'll show you this other cool thing, it's not a bio thing, we're just going to say solids never settle in a suspension. Okay. And I'm going to scratch that. Sorry, I looked at the wrong piece, and I trusted my notes more than my brain. Solids eventually settle. Now, this doesn't change my example that I want to deal with. I'm just going to change the way I'm talking about it. Sorry, I got goofed up there. Okay. And actually, I don't know whether this is truly suspension or not. We'll check this out tomorrow. I will not put this thing back in here. But we will look at this because if we haven't seen it. So I'm going to pause this. If Fredward or, oh yeah, what the Fred? I forgot to do that. My bad. If you guys want to see the cool magnet thing that I'm going to do real quick, ask about it when you get back to class. Right off the bat, do you think that's a suspension, or do you think, is that going to settle? Is the iron going to sink?
No.
We'll find out tomorrow. If it does, we call it suspension. Now, milk, we've already decided, is not homogeneous because those little fat globules are different sizes. You ever went to get your milk that's not rotten? I don't want to think about rotten milk. You ever looked at, do you shake your milk before you drink it? You don't, you do? Okay, follow-up question. Do you have to?
I don't know, it's just like when it's empty, like when I take anything, like I just shake it. Then
Well, sure, let's pretend let's completely full, brand new gallon, you're about to open it. Are you going to shake your milk?
No.
Because you don't have to mix it up because it's never settled, right? It would really gross me out if, and you see it happen with like yogurt. When you open yogurt and you eat it after one day, when you open it the next day to get your next bowl, there's a bunch of liquid on top, right? It's separated itself. That doesn't happen with milk. Okay, so yogurt would be an example of the suspension because all that whey protein, that liquid on top, don't dump it. That's whey protein. All that liquid settles, that's the suspension. Now, in contrast with that, we also get these things called colloids. Now, these are the same idea. This thing that I just showed you with those iron filings, that is either a suspension or a colloid, depending on what we see happen by tomorrow. We're going to define a colloid as a heterogeneous mixture. So I'm just going to say a hetero, just for short, if you guys are cool with that. A hetero mixture that never settles. And I had them mixed up in my head initially, so I'm sorry about that. A heterogeneous mixture that never settles. So, milk and yogurt are essentially the same things. Yogurt's a suspension because it'll separate from the whey protein, that gross looking liquid. Milk doesn't. Milk is a colloid. Okay, tomorrow, just so I know where we're starting off with, these should have been both dashes, and that's my bad. Tomorrow, though, we're going to jump right in and finish a section where we're going to talk about acids and bases in a little more detail. Cool. So that's where we'll jump in tomorrow, and we get a little bit of chemistry action happening, but we'll deal with it when we get there.